we are going to get started. Anytime you are given a two-way table, okay? Anytime you're given a two-way table, it just means, in this case, you have age group and you have employment status. That's what it means to be a two-way table, two different categories, so to speak. You always want to figure out the totals, okay? Because you never know when you're going to use them, all right? So anytime you have a two-way table, you always want to compute what the totals are for each, okay? So that's what we're going to do first. Even if you don't necessarily use them, it's always a good practice to do so. What is the total amount of full-time? Danielle? 1581. Okay. How about part-time? Louise? 775. Should be. How about unemployed? Assad? 823. Okay. So then we go through and then the age group totals. And the age group totals are a lot that we're going to use. Okay. Total number from 0 to 17. Go ahead, Daniel. 559. All right. 18 to 25. Taylor? 536. Good. Okay. 26 through 34. Sawyer? Good. Okay. 35 to 49. Harris? 864. And 50 plus. Louise? 778. Making a total 3,179 that were surveyed. Okay? So, the reason we do that is we never know what we're going to need. Okay? So, if we look at A, if a person in this town is selected at random, find the probability that the individual is employed part-time given that he or she is between the ages of 35 and 49. What do we got? Nolan? Excellent. Okay, 179 over 864. One thing to remember, whenever after given, that's a key word, okay? That is your denominator. Then you look out of those ages between 35 and 49, how many of them were employed part-time, okay? Now the next one, if a person in town was randomly selected, probability that an individual is unemployed given he or she is over 50. Go ahead, Grace. Excellent. 173, 778. Okay. So again, very basic in terms of given problems, the defendant probability. A person in town is chosen randomly. What is the probability the individual is employed full-time given he or she is between 18 to 49? Louise? Excellent. Okay, that is the reduced fraction because it's 18 to 49. So 18 to 49 includes these three. Okay, so you have to add together 536, 442, 864 as your denominator. Okay, so that came to 1842, and then your numerator, out of these three, which ones are employed full-time? So it's 185 plus 348 and 581. So before reducing, 557 over 921 is what Louise said. Okay? Then the next one for D. A person from the town is randomly selected. What is the probability that the individual is employed part-time given he or she is at least 35 years old? Anybody? Same people keep answering. Thank you, guys. Go ahead, Caitlin. Excellent. Okay. At least 35 years old. So since it's at least 35 years old, it's going to be these two as your denominator. Okay? So you add those together, then you look for part-time, and again, it's these two. All right? And any questions about those few? Okay. The same thing with practice. Okay, same thing. We're going to look at number 10. So the 4 people that have answered, 5 people that have answered, majority of you now are going to be either called on or please answer. Okay? Those guys are off the hook. So, conditional probability, we're at the marble one right below it, right below the one we were just working on. So if you look up here, this is where we just were. We're now looking at this one. Okay? Conditional probability means dependent. Okay? Consider a bag of marbles, 3 blue, 2 red, and 5 green. Okay? 3 marbles are drawn in a sequence. However, not all the time are we going to draw 3 in these particular cases. Okay? A keyword there, without phrase, without replacement. So it's not being put back in. Okay? So what is the probability the second draw is blue given the first draw red has already happened? Wes? Good. 3/9, which is 1/3. This first draw red already happened. So instead of 10 marbles, we are down to 9. Okay? And out of those 9, there's still 3 blue left. Okay? The second one, probability. The second draw is blue given the first draw was blue. Rosanna? 2/9. Excellent. The denominator also decreases because we got rid of 1 marble. However, that marble was already blue, so we have to get rid of 1 from 3. Okay? The next one, probability the third draw was blue, given the first draw was red and the second draw was blue. Yep. 1/4. It was 2 out of 8, which is 1/4 because you already took 2 out. Okay? Probability first draw blue given the first draw was red. Nolan? 0. Good. Can't happen. Okay. So as I mentioned before in previous lessons, probability with cards is seen everywhere. Okay? So you want to just remember the facts of cards. Okay? Characteristics. We have 12 face cards, which are king, queen, and jack. Okay? 12 face cards, king, queen, and jack. There are 4 suits, clubs, diamonds, hearts, and spades. There's 13 cards in each suit. Okay? So, knowing that information, probability of drawing a queen given you've already drawn face cards. So how many face cards are there? 12. Out of those 12, how many of them are queens? 4. So this notation sets up your probability for you, your fraction. Okay? Same conditional. This is saying you've already taken out 12 of the face cards. Out of those 12, how many of them are queens? So it's 4 out of 12. Okay? Then the next one, probability of drawing an ace, given we've already taken out the letter cards. So how many lettered cards are there? Brayden? Lettered cards. Genevieve? 16. Ace, king, queen, and jack. Out of those letter cards, how many of them are aces? Addison? Good. Okay. And number 3, probability. A heart with a number given you have red cards. So how many red cards are there? Liam? 26. Out of those 26, how many of them are hearts with numbers? 9. Excellent. Okay. And the next one. Probability a card with a letter given you have kings. How many kings are there? Danielle? 4. Out of those 4, how many of them have a letter? How many? There's 4 kings. How many of those kings have a letter on them? Sawyer? 4. 4 out of 4, which is 1. It's okay. Okay, the next one. Probability a number less than 6, given if it's a face card. So Blake, how many face cards are there? 12. Out of those 12, how many of them have a number less than 6? None, right? 0 out of 12, which is 0. Okay. The last one, probability an odd number, given it's a numbered card. So how many numbered cards are there? Numbered. Emma? 36. Out of those 36, how many of them are odd? Odd numbers. What's that? Sawyer? 16. Okay, so we have 36 numbered cards. God bless you. Which are this little inch here. Okay, and then out of odd numbers, 4 3s, 4 5s, 4 7s, and 4 9s. Okay, so that's how we get the 16 out of 36, which is 4 9s. Okay, so with this same packet, go back a page, go back 2 until you see this. Until you see where it says studied, passed, failed. Good? All right, we're going to go to the bottom here. Excuse me. Where it says out of 120 students, we will be filling out this two-way table based off of the percentages given. Okay? So, we have 120 in total. 40% of students are juniors. So how do I find that? What do I do? Nolan? Good. 120 times 0.4, which is how many juniors? 48. Good. Okay? The next one is 25% of juniors study biology. So what do we do there? Louise? Excellent. And how much is that? Go ahead, Liam. 12. And where would that go in the chart?
That would go within sections of juniors in biology.
Okay. Then we have 35% of students are seniors who study physics. How do we find that amount? What do we do? Brayden? Good. So how many seniors study physics? Danielle? 42. Good. Okay. then 45% of students study physics. So how do we figure that out? Go ahead, Grace. 5, good. And how many students in total study physics? 54, excellent. Okay. And then 30% of students study chemistry. What do we do to find that out? Liam?
20 times 100.
Good. And what do we got? How many students study chem? Go ahead, Taylor. 36, good. Okay, so based off that information, we just saw pieces of this two-way table. So your task number 1 is to complete the two-way table. Okay, that's number 1. And then answer the questions below and put them in reduced fraction form. Okay? So, table first, then answer the questions below, B through I, in a reduced fraction form. Go ahead. Okay. So you first had to complete the chart, okay, which you see as follows. All right. Now, some of the questions, depending on the wording, can go either way. So, what is the probability that a student studies biology? So you're looking at all the students, 120, out of those 120, 30 study bio, which reduces to 1/4. Okay? Then anytime it says and with a two-way table, you are looking for their intersection. Okay? Where they both occur, you do not have to multiply or add whatever else like that. You're just looking for the intersection. So, what is the probability that a student is a senior and does not study bio? Okay, so you look at the seniors, does not study bio is 12 plus 42, which is, oops, sorry, senior and does not study bio, so you're adding these two together still. 54 out of 120, which reduces to what? 9/20, good. Okay, then the next one, what is the probability that a student is a junior and studies chem? So junior in chem is 24 out of 120, which reduces to 1/5. So what's on the board is correct for D. Okay. Then for E, what is the probability the student is not a junior? So you're just looking at seniors. It's 72 out of 120, which is 3/5, which is on the board correct. Okay. Then the next two kind of ask the same thing, just differently. Okay, some of the wording. What is the probability that the student does not study bio? So 36 plus 54 gives you 90. 90 out of 120 reduces to 3/4. Okay, which again, correct on the board. Then the next question, what is the probability that a student chosen at random studies chem or physics? So again, 90 out of 120 reduces to 3/4. Now H, what is the probability of randomly chosen junior? So instead of 120, we're now looking at just juniors, which is 48. Okay, out of those 48, how many of them study physics? 12 out of 48, which reduces to 1/4, which is correct on the board. Okay, and the last one, what is the probability of randomly chosen chemistry student? So now you're just looking at chem. Denominator would be 36. Out of those 36, how many of them are seniors? 12 out of 36, which is 1/3, which is also correct on the board. Okay? How many of you did get all of those correct? Good, good, good. Any questions? Okay. So, today, you probably noticed on the answer key from the homework, there were some symbols in there or whatever that you probably had no idea what they were, because that's what Miss Betta is used to, using those symbols, so I apologize. That's where those symbols are going to come in today, okay? We are getting into set theory, which has to do with symbols. The last few classes that I ran this went pretty good, okay, which I expect the same, right? Keep in mind you do have a quiz on probability next Wednesday. I was going to do Monday, but we have a ton of practice that we could do, okay, which is on Wednesday. We're finishing up 3.3 today. On Thursday, expect to have a warm-up first, then a formative, first round of practice and review, an exit ticket, okay? On Monday, coming right in with the formative through quizzes, okay? Formative, get to review number 2, okay, which might be stations or whatever it is, then an exit ticket as well, okay? You get this feedback right away, all right? So you know where we're lacking, what do we need to do, plus there is a full review as well, okay? So there's a lot of practice to get this down because, again, this part is all over the SATs, okay? So, which are happening next month, I think, all right? So take out your notes. And turn to page 9. Take out your notes and turn to page 9. All right. So, all this stuff with Venn diagrams and whatever else we're looking at, we use set theory for it. That's the whole name of it, okay? Where you're looking at specific sets. So, a set is a collection or objects, okay? There's definitely no repeats. You will see it's denoted by a capital letter, okay? So, for example, set A. Those squiggly brackets are back because this is set notation where you're listing, okay? So set A, 1, 4, 6, 10, 12. Set B, all ninth graders is an example. Set C is turtles, penguins, mice, and bears, okay? Those things that are within the set are called elements. Elements make up a set, okay? To denote if an element is contained in a set, we use this symbol, okay, which looks like an E. Right? So, for example, 4 is in set A. However, 5 is not. If something is not in a set, it looks like that E with a line through it, okay? So, in set B is all ninth graders. What would be an example that is not in set B? Louise? 8th graders, 10th graders, whatever. Good. Okay. Turtles is in set C, but dolphins are not. Okay. So that's what the notation is for that E there. Okay. So now, here's the Venn diagram. What are the elements of set A? Go ahead, Liam.
1, 2, and 3.
Excellent. Okay. And set A is 1, 2, and 3. What are the elements in set B? Yes, Diane. 3, 5, and 7. So anytime we're looking at a full set, it's this full circle. Okay. What elements do A and B have in common? Go ahead, Seth. 3. What elements does set A have that set B does not? Go ahead, Liam.
1 and 2.
1 and 2. And again, if you notice, I'm rating these all in set notation with the squiggly brackets and listing. Okay? Turn to the next example, which you're going to try. You have 2 different events here. Animals and things that fly. Okay, so there's your Venn diagram. I want you to answer these 3 questions. I'll give you a minute. Go ahead. Okay, how many elements are in set of things that can fly? There's 7. There's 7 elements. Good. What elements are animals that cannot fly? Danielle? Good. Good. Okay. Write the set of animals that can fly. Go ahead, Nolan. What are animals that can fly? Okay. So, the way this was asked, okay, animals that can fly is what they both have in common. Okay? So, some of the notation we will see. Okay? U stands for the universal set. So, if I was to divide this class into set A, 9th graders, set B, 10th graders, set C, juniors. However, all of you would be a part of the universal set. Then you would go into your individual sets. Does that make sense? Okay? The null or empty set contains no elements. Okay? So if I had like a set D that was seniors, that's an empty set. There's no seniors in this class. Okay? Does that make sense? All right. A notation that you probably saw on the key. Okay? The intersection. This upside down U is called, represents and, what they have in common. Okay, it's the intersection of the two, like you would see on a two-way table. It's what this was asking. Okay, and means both. When you have U, that stands for union. This is very important because the majority of times we forget about that middle part. It stands for or. It's A or B or both. So it also includes the intersection. That's why both circles are fully filled out. Okay? The next one is called the complement. Has that little C or a line over it. Another notation would be like that. Okay? It's elements that do not belong in A, for example. So if you notice, everything is shaded in except the full circle of A. Okay? So the first few, we're going to write what this means in words. Then we're going to apply it one way and another way using a Venn diagram. Okay? So, the upside down means what? And or. And. So, in set A and set B and in set C. So where all three have something in common. Okay? That little C means what? Yep. Okay, it's part of the outside. So part of it is the outside. It's not in B. Okay? So all of B would not be shaded in. A and the outside. Okay? Then we have that U, which represents what? Or. So in set B, or in set C, or in set D, or in all three. So where they all intertwine. So if I had a 3-set Venn diagram, that's what it looks like. Okay? If it's or, all of that would be shaded in. Okay? When you have a 3-set Venn diagram. Okay? Now for D, this means that line not in A or B or both. So this notation would just be the outside. Okay? In terms of shading. Okay? The more we do with the notation, the easier it's going to get. Okay? So we have an example here. We have in set F our Haley and Taylor. In set G, Mom, Dad, Taylor. In set E, Mom, Haley, Muddy. And the universal set is Mom, Dad, Haley, Taylor, Muddy. Okay? So those 5 names will make a Venn diagram if you were going to create it. Okay? So now, we want to know who or what is in F and G. So what name is in F and G? Sawyer. Taylor. Okay? Then we have F or G or both. And again, no repeats. So who is in F or G or both? Danielle? Good. Good. The next one is who is not in E. Who is not in E? Addison. Anyone else? And Taylor. Good. Dad and Taylor are not in E. Okay. So far, A, B, and C, how are we feeling? We okay? Okay. So now we have F and G and E. So basically, is there any name that is in all 3? No. So if there's no one in that notation, what do we say? Null or empty set. Okay. All right. So now we start combining a few of these things. Okay. So this is not in F and G. So basically it's saying it's not in the intersection. So we already found the intersection, which was Taylor, right? So who is not in that intersection? Liam.
Yeah.
Who else? Who else?
Money.
Uh-huh. Who else? Yep. Good. So what that is saying is excluding where they're intersecting. Okay? Not in F and G means not in this intersection. Who is not, we're eliminating that name, and it's everybody else. Okay? And the last one should be F. What is in not, actually, what's not in F, but it's in E? Not in F, but in E. What's in F, but not in E? Grace. Careful. Not in F, but in E. You're correct. Good job. Good job. Excellent. Okay. So it does get a little tricky when you start combining a lot of these symbols together. but take it one step at a time, okay? Some of you are more on the visual side that like to see this displayed in a Venn diagram, which could be easy. You could do a Venn diagram with this, 3-set Venn diagram. We're going to see a 2-set right here, okay? So we're going to practice filling these out. We have 2 sets, set A and set B. Set A contains January, February, March, April, September, and December. Set B contains April, May, September, November. The universal set, so this whole Venn diagram has to include all 12 months. Okay? What months are both in set A and set B? Assad? April and September. Okay. Knowing April and September are in both, what months are only in set A? Taylor.
January, February, March, and December.
Excellent. Good. January, February, March, December. Good. What months are only in set B? Liam?
May and November.
Excellent. Okay. Now, are there any months that are unaccounted for? Louise? June, July, August, anything else? June, July, August, October. Excellent. Okay. So again, notation. A and B. Which months are in A and B? Brayden. Good. Okay. What are not in A and B? So what months are not in the intersection? Go ahead.
July, August, October.
Anything else? It's and. So what is?
January, February, March, December, May.
Perfect. Good. So some have asked in, well, let me just finish writing. Okay. Some have asked, does it need to be in order? Like, do the months or numbers have to be in order? No. That little stuff, I don't care about. I care about if you list everything that needs to be in there. If you want to put it in order, go right ahead. However, if you did it like I just did, you're fine. This is more important than putting them all in order. Does that make sense to you guys? Okay, especially when it comes to numbers. I don't want you to sit there and waste time of putting them in order. Just write them out as you see. Because you understand that concept. That is more important to me than if you could put them in order. Okay? So then, the last one. A or B or both. What do we got? Nolan. Perfect. January, February, March. Good. So, also people have asked, is there a shortcut to doing this? No, you have to list them all out. It's set notation. So, numbers and objects, months, whatever you're looking at has to be listed out. Okay? There's no abbreviated way. All right? So, we're going to get started. You guys are going to try this one on your own. Okay? You have set F and G, and the universal set contains numbers from -3 to 18. So this whole Venn diagram has to include those numbers, -3 to 18. Okay? So, as far as your integers, -3 to 18, which integers were in both F and G? Go ahead, Rosanna. 5, 8, and 12. Okay, so that one in the middle, and then you had 2, 7, 9 in F, -3, 0, and 17. Then, since it's -3 to 18, you had -2, -1, 1, 3, 4, 6, 10, 11, 13, 14, 15, 16, and 18. Okay? Those are all the numbers that should be on the outside. All right? What is in F or G or both? Go ahead, Cyan. Perfect. Okay, good. All right, so for the next few, okay, we're going to talk it out, talk about it. What I post, you guys are going to see them all listed just in case you missed a number when we go through, okay? So this is 17 if you can't tell. What is not in F? Danielle? Okay, good. So it's -3, 0, and 17, and everything on the outside. Okay? And what is not in G? Liam?
7, 9, -2, -1, 1, 3, 4, 6, 10, 11, 13, 14, 15, 16, 18.
Excellent. So not in G, 2, 7, 9, and everything on the outside. Okay? Then for E, what is not in F and G? So we're eliminating that intersection and listing everything else. So 2, 7, 9, -3, 0, 17, -2, -1, 1, 3, 4, 6, 10, 11, 13, 14, 16, 15, 16, and 18. Okay? So we're just eliminating that middle part. Then the last one. What is not in F, but it's in G? Excellent. Good. Okay. So that has concluded our probability unit. Okay. You guys will be working on, in your practice packet, okay, in your practice packet, the 3.3 practice. So it's only one page, front and back to the last page. Okay, 3.3 practice where it says set theory. Okay, you may get started on that now.